All right. Hello. Hello, openHAB community. My name is Dan Cunningham. Also, you know me as Digital Dan on the forums. And I'm super excited here to host the openHAB 2020 Virtual Meetup. I'm a longtime contributor to the project and a member of the openHAB Foundation. And I'm going to kick it off here with an agenda for today's presentation. So we have 5 great presentations. Our presenters are Kai, who's going to be doing an overview of openHAB, Yannick, who's going to be giving us a tour of the openHAB 3 new UI, and then Marcus is going to be giving us an update on openHABian, our openHAB Raspberry Pi distribution. Christoph is going to be doing a presentation on Bayesian sensor aggregation, and finally Patrick will be doing one on innovative input devices for openHAB. A little housekeeping around the Q&A. So if you look to the right of your screen, you will see a chat section. We are going to use time at the end of each presentation to take the chat questions we see there, and we'll display them on the screen and answer them the best we can. We'll spend roughly 5 minutes after each presentation for Q&A. There is a 10 to 15 second delay in the stream, so if you ask a question, it may be a little bit delayed before we get it. And with that, I'm going to go ahead and bring in Kai here. And Kai, I'm going to kick it off to you to start this off.
Thank you very much, Dan, and welcome everybody. So yeah, some of you might know me. I'm Kai in the forum, so in case you haven't met me yet. I'd like to talk today a bit about the evolution of openHAB since its inception many years ago to where we currently stand, and to give you some insights on what led to certain decisions we took for the upcoming openHAB version 3. So the history, the story of openHAB, well, starts very simple. It starts with a house. And that's the house I built for my family in 2008. And I took the opportunity to put in a lot of cables and switches and all kinds of stuff, and required something to actually control all of that and have a nice solution on for that. At that time, the standard solution was to put up a large touch screen on the wall that was incredibly expensive, together with a server with proprietary software on it, which was again incredibly expensive. And as being a software developer myself, I didn't really want to invest in that road, especially as some guy just invented a small touchscreen device a year before, which seemed to be just the perfect thing to control the house and interact with that. So luckily for me, I found actually an open source software at that time that provided a web UI that was running on iPod Touch and connecting to all my stuff. The project was called Mr. House, and I spent about 1 year to get familiar with the source code. And after that year, I had to tell myself that I really tremendously failed in getting into that and liking that code. So being a Java developer, I said, well, it can't be that difficult. Let's build a small Java framework, do some connections, modules to certain technologies, put on top a small web user interface, and use the JBoss rules rule engine to put some automation on top of all of that. And that was more or less all it took, all I needed. Pretty nice. I thought, okay, when I spent the whole effort in building that, maybe it's useful for somebody else. So I actually took the decision to do that open source from day one already. And indeed, few people showed up that liked it, that used it themselves. Some of them were developers, and so over the time, more and more contributions came in, and the system evolved. number of bindings increased quite a lot. New types of add-ons were invented, like for voice and other stuff, persistence layer for storing our things. New user interfaces were built on top of that, and the tool's rule engine actually proved to not be a good choice for openHAB, since it was pretty large and slow and didn't integrate well with the rest of the code. So we implemented our own lightweight rule engine implementation, designing a rule language that was very close to what rules offered, but which nicely integrated directly into the openHAB concepts. Also on the rule engine, it was designed in a way that it's extensible, so adding rule actions to do all kind of more complex stuff than that you would want to fire within the rule. So that was more or less then the setup of openHAB 1. It grew, and more and more people were using it. And also more and more people were asking that they would actually want to use the core framework for their own kind of solutions independent of openHAB. So building, for example, commercial gateways on top of that, or other things. And so in 2016, the decision was done to move the core code base to the Eclipse Foundation, becoming the Eclipse Smart Home project. And so openHAB version 2 was then one solution built on top of the Eclipse Smart Home framework. Since that move to the Eclipse Foundation meant that from the code side, all the namespaces were changed and nothing was compatible anymore there. We directly introduced the 1.x compatibility layer to allow our users to directly continue using all the add-ons they already had in place to make that work there. A few things like voice and other stuff was directly ported to the new namespace, also the user interfaces and the rule engine, but the rest was more or less working as before. Now, the main focus of Eclipse Smart Home was then really to spread this framework to non-tech users, meaning that more or less everything should also be feasible to set up and configure through graphical user interfaces and not just through pure textual configuration. So the first thing that really happened on Eclipse Smart Home was to design a completely new binding API that now allowed bindings to automatically discover stuff on your network, to self-describe the devices and their capabilities through the things and channel concept, and also to completely allow all setup and configuration through the REST API so that that can be used from user interfaces. Likewise, a new rule engine has been developed to more or less achieve the very same thing, namely building rules from prefabricated modules and just putting them together, assembling rules through graphical editors. And to support all of that, the paper UI was developed as an administrative user interface to make use of all these new functionality. Besides that, especially Yannick was very busy building new kinds of user interfaces that everybody likes, and also some others were added here. So we have quite a huge number of UIs on that. And this is more or less the structure and the setup that all of you know of the current official release, openHAB 2.5, and where we stand on that. Now, the triggering point to think about openHAB 3 was actually not so nice event, let's say. It was more or less the fact that the Eclipse Smart Home project more or less dissolved itself, meaning that the maintainers that were on the project were, to a large extent, or almost everybody, come from the openHAB community only. So while many other people were using the framework for their own solutions, nobody was willing to really step up and invest their time in helping maintaining that framework. And so from an openHAB community and maintainer perspective, we said, well, it doesn't really make sense anymore for us to keep that as a separate project with its own release cycle, with its own build servers and systems all around, with its own community forum. So we said, let's go for an openHAB version 3 and reintegrate this code again into the openHAB project. So this has now become the new openHAB core framework again. And another side problem we had was that we didn't have any maintainer for the paper UI anymore. And from the openHAB community, there was also nobody willing to go into paper UI and taking over that code, because it was rather in a bad shape, and the better choice was to say, well, let's start something new, modern, and nice from scratch on top of that. And so the paper UI was dropped, and instead we're now talking about the new main UI, which most of you will have seen already, and where we will hear much more about it from Yannick later on. The idea was with the paper UI that it really covers a lot of the functionality that was also a bit distributed on other things, like doing nice setup of your system, so you won't need the home builder anymore. Doing also the control interface, so you don't necessarily need any additional UIs anymore. And so as a result of that, we more or less removed many things there and combined that all in the new UI. I hope Yannick is fine that I also removed here Hubbard, which is not completely correct. In the slide I removed it, but we will still ship Hubbard with openHAB 3. But the intention is really to say, well, also the functionality of Hubbard, meaning mainly the natural language interaction, that should on the long run also be migrated and found in the main UI to really make it overall much simpler, that you have a single UI where you can find all of the functionality. Now, another simplification on that, which was also driven by the fact that the main UI was done from scratch again and should really improve the user experience of openHAB overall, was to say, well, we still have the 1.x bindings to the compatibility layer, which completely behave differently. They cannot be configured in the same way as the new bindings. We also have the actions, while actions are now in the bindings themselves, so they are contributed by bindings because they often are linked to certain devices and you need access to them in order to provide the action. So all of that were more or less outdated concepts. And that's why we also decided to remove the complete compatibility layer with the support of the old add-ons here. As a last thing, we also combined the two rule engines into a single one, which is essentially the next generation rule engine, but it has been enhanced to also natively directly support the rule DSLs that we have. And so that even DSL rules are now maintainable through the user interface and work exactly the same way as all the others. So as a summary, the openHAB overall architecture is now much, much cleaner and simpler again in comparison to openHAB 2. And that should, on the one side, make it simpler for the developers to really have it as a clean code base, but also for the users, because it's not such a huge choice of different UIs, of different concepts and things, which are pretty hard to learn, but it's much, much easier then to get into that system. that's more or less the goal here. And yeah, I hope we reach that. Now, we are aware that many of the existing users of openHAB might still require 1.x add-ons, bindings here, and can't live with simply dropping that because there is no replacement available. That's why we came up with the idea of the remote openHAB binding, which, well, kudos to Jan, was implemented very quickly and nicely. And the idea here is to really allow people to still run an openHAB 2 instance with the specific bindings and things that they need on that, but integrate that into an openHAB 3 environment completely and smoothly, so that, yeah, you can more or less have the best of both worlds and have an easy transition here. Nice side effect of the remote openHAB binding is that it's not only for keeping the legacy support available here, but that it also allows you to quite easily create distributed setups. So the remote openHAB instance can also be an openHAB 3 instance. For example, if you need at some other place where you have a serial connection to certain devices, where you need local proximity, or also Bluetooth, which might have otherwise range issues. So you can really have multiple instances, but combine them into a single system. Now, under the hood of the core framework, we also invested quite some effort to make that future-proof and yeah, nicely maintainable for the future. So first of all, we updated the Java version that we support in openHAB, which meant that we have many new language concepts available that allowed us dropping older libraries like Google Guava, Apache Commons, and other stuff. We also cleaned our own APIs to really finally remove methods that were deprecated since a long time and not have that in the code base anymore. There is a new JAX-RS implementation which powers the REST API, and the previous one in openHAB 2 was not really a good fit for dynamic environments using OSGI and loading add-ons at runtime, which caused many issues, and the new one will behave much, much better there. Eventually, we have some REST authorization. So by default, the administrative endpoints are secured and not directly accessible to everybody. And optionally, you can also secure the endpoints for the normal users. Last but not least, we covered more or less the whole code with null annotations, which should also make it, well, less error-prone, more stable, and yeah, reduce the risk of running across null pointer exceptions from the core framework. Now, when we release openHAB 3.0, it won't be complete, finished, everything there, but further things will have to happen in future then as well. For example, we definitely still need a replacement for the Eclipse marketplace, which we don't yet have. There are initial discussions, but nothing ready to be used yet. We will have more add-ons for the whole automation, starting from helper libraries for the scripting things, to also strengthening or bringing the concept of rule templates into the system and bringing that to the community to allow much more easily to share complex rules, complex setups with others, which should also nicely go hand in hand with the marketplace. Persistence is one of the last features where you still need textual configuration for that. And so that's also something where we should look at allowing here administration through a user interface as well. And yes, with the current speed of development of the new user interface by Yannick, there will be also many further user experience improvements of the whole system, where we also need to further do things in the core framework to support the UI to make it even easier to set up things and guide users through the whole processes. Last, I want to mention that, well, what I always say, there is no dedicated roadmap that really is carved in stone and that anybody can commit to, because an open source project like openHAB really depends on all of you as a community and what you contribute. So what comes up next really depends on what features you think of, what you like, what you implement. And the maintainers of openHAB really just make sure that the guardrails are clear, that the overall architecture is kept, and that openHAB evolves as a solution in a good way forward. But yeah, we need all of you for that. And with that, I'd like to thank you for your contributions and your commitment to openHAB, and also for joining today and listening to me. And we can go to the Q&A session then.
Awesome. Thank you, Kai. And if you've got questions, go ahead and enter them now into the chat, and we will read them. I did notice a few kind of questions coming in. I think there was some chatter about maybe the longevity of the existing UI, specifically HAB panel and basic UI, and there was some confusion on whether those will be going away too. Do you want to talk about that a little bit?
Yeah, sure. And that's a very good question. So they feel a bit at the side on this picture I showed. And yes, there are certain overlaps with the main UI. As I said, it can be used for really controlling your system as a user, not just for administration tasks. But since really basic UI and HAB panel have a huge user base and community, we definitely decided to keep them in the project, so that it's not a hard cut or switch and force anybody to go to the new UI. Especially for HAB panel, there are so many community add-ons, specific widgets and all of that, where the main UI isn't yet a suitable replacement for that. So yes, we'll definitely keep that. And as I mentioned, we also keep HubBot so far. And at some point in the future, maybe we say, well, okay, everybody is really using the main UI, it covers everything, and then we can say this could become less important, and maybe in future those things are dropped if nobody is willing to maintain it anymore. But okay, for now, that will be still in place.
Great. There's some really good questions here about, are we gonna, here, let me post one of these here. So there's a few people asking about configuration files versus what we'll hear about from Yannick in the new openHAB 3.0 UI, which is more user-friendly and allows you to use the system without configuration files. Do you want to talk a little bit about, are we going to keep supporting these files going forward? Are there benefits or trade-offs? Who's the intended audience for each one?
Yeah, sure. I know that's usually a very controversial question, and the short answer here is yes, we will keep it. I've seen many discussions on the community forum where some people really say, no, everything should be UI only. Others say, no, everything should be text file only. So we will never find the one way that suits everybody. Both has its pros and cons. And so we will continue supporting both ways here. So textual configuration is really still completely, fully supported, and it will stay that way. And yeah, the UI and the concepts there, it's really more or less getting up to the same level to be able to also configure everything through the UI, but it's not meant as a replacement.
Fantastic. And then the last thing I'll probably ask before we move on to the next one is, I think there was some talk about what's supported in openHAB 3 in terms of bindings. And by the way, I personally use the remote openHAB binding. It was amazingly easy to set up and use, and the development pace on that has been pretty amazing. So that's really easy to use and connect to a 2.x system. Do you want to talk just briefly where people can find out about if their binding is supported in 2.x or 3.x I think we have a list of depreciated bindings on one of our sites.
On the openHAB add-ons repository, there is the one pinned issue where a list is maintained about bindings that existed in openHAB 1, which are already ported as an openHAB 2 or now 3 binding. And yeah, that was also a bit driven by this community poll, how many people are actually using it, where is it worth to spend the effort to port the bindings. So for the details, that issue can be looked at, I think. And yeah, for really the ones that are not ported to as an openHAB 2 or 3 version yet, the remote openHAB binding would be the solution to keep that going.
Okay, great. I think with that, we'll go ahead and move on to the next presentation and keep this not running too much longer here. So thank you, Kai, very much.
You're welcome.
And I'm going to bring in Yannick here, who will talk about the new UI in openHAB 3. So Yannick, I'm going to hand it off to you.
Okay, all right, thank you, Dan, and thank you all for joining us today. As Kai says, we are really excited to have a brand new main user interface for openHAB's next major version. And I know a lot of you have already tried it at this point. That said, I understand there are a lot of questions and anticipations about it, so I try to provide some answers and showcase the major new features and concepts, and also try to convince you that it's not, after all, such a radical change. I only have a couple slides for you today, and I won't spend too much time on them because we'll quickly get to a demo where I'll start a brand new instance from scratch and hopefully show that doing everything from the UI is now actually a quite viable option. So let's get started. First, a little bit of history. Much happened at that time, as you might or might not know. Long story short, it has been almost 2 years in the making. It was decided to go ahead and consolidate the various UIs that openHAB 2 had, and many of them seemed a little bit redundant, and so having a single main UI built with modern technologies was desired. So 2 years later, we're on the verge of delivering, and the release does not mean it's the end of the road, of course. There is still a lot of polishing up to do, and minor openHAB 3 versions will see there are a lot of improvements, I'm sure. So some of the design goals that we focused on. We tried to build something that would appeal to everyone, even the more casual users. I mean, your family members, your wife and kids, while you, the administrator, will have the complete sets of tools available to you. We predicted that these non-technical users are more likely to be using openHAB and the UI on the phone. Therefore, being as friendly as possible in that regard was a must. That includes looking like an iPhone app when run on iPhones, like an Android app on Android. And that being said, it was also important not to dumb down the interface too much for power users on a desktop. since it had to be usable for them as well. It's also perfectly understandable that there's a wide range of interests out there. And while everyone here is passionate about home automation, not everyone is necessarily passionate about building UIs. So we try to keep that in mind without preventing those who have an interest in building nice-looking things to their taste to be allowed to do that. And finally, this is important, while we now have finally a main general purpose user interface and have deprecated a lot of them, some specialized users UIs are staying. So you will find your app panel, you'll find your basic UI, and you'll find others that are working well for many. The mobile apps and the sitemaps are also not going away. Now, quickly, a more technical note. We're trying to appeal to new contributors as well, since quality contributions are very much desired. So if you want to jump in, you're very, very welcome. This is cool tech, actually. It's also completely separate that the Java development environment, like the ones you need to build bindings and the like. So if that is not your thing, you can still give it a try. And again, if you're interested, please step in. But you can contribute in a number of ways, not just code. There are a lot of things to do on documentation, on supporting users, on proposing new ideas. This is all important. So that's it for the slides. And now let's go straight to business. So I'll try to spin up a new instance from scratch and show you what you can achieve in maybe half an hour or 40 minutes or so. So you have a number of options to run openHAB. Here I simply downloaded the distribution and extracted the .zip file. And here you go. I just started it while we were listening to Kai. And this is what it's looking like when you start it for the first time. So we see that the UI is on that port 8080. So we'll just open up a browser here and go to that port 8080. Okay. So it's asking me to create a new administrator account. This is the first user that you will create. So I will go ahead and do that. Next, we have a brand new setup results. It asks from some regional settings first. You can skip it if you want, but it's actually very short and quite useful. So let's take it. Next, we can specify the location. It's optional, but some bindings will rely on it and use it for instance, sunrise and sunset times and the like. So we can ask the browser to provide the current position, or we can choose it on a map if you prefer. And finally, we can install some add-ons to get started. As you can imagine, openHAB is pretty useless unless you install some bindings to connect to things. So if you happen to know which one you need right away, you can install them from that screen. So here I'll choose HTTP, MQTT. Okay, I'll just search for it. And JSON path, because we may do a little bit of JSON extracting later. You have this NIB heat pump, and I'll install the Abbott as well. So once you're done choosing the add-ons, you choose install here. You have the link to the documentation if you want. But go ahead and install. So a little bit about what we'll try to do today. I'll try to have two MQTT things working. First, this little plant sensor that many of you probably know. I don't know, Dan, if you can switch back to me for a second. Or not. You have it's a very cheap sensor that you can have for $5, and you stick it in the soil next to a plant, and it will report some readings. Oh, and there you go. Welcome to openHAB. The second thing I wanted to install is some electricity meter, also via MQTT. And another thing over HTTP. So this is the home page, the main screen, and it's pretty empty at the moment, and honestly not particularly appealing. So that would be an area of improvements in the onboarding process. We could give some better hints here instead of this new, maybe this empty space. There's a tutorial being written that could be linked to, and some bullet points about what you do next, for example, could be shown here. We'll see what you can do. And you also have some tabs at the bottom. We'll have a look later at them. For now, they are empty. And we have some things on the left. For instance, you can go to the profile page, and there will be more stuff over time in this page too, but for now, this is where you can generate some tokens to act as to use as credential for the API, which is not partly protected. You can change your password. You can list your current sessions. You can sign out, etc. In the About page, you can define some UI related options that are stored locally, like the colors, the theme, if you prefer one in particular. For instance, you have the Android theme here, change a little bit. You have the iOS theme, you can put dark mode, and so on. You can also retrieve some valuable or more or less detailed info about your instance here that you can and should copy and put it in the issue that you open. That's very useful to us. So all in all, there's not much you can do except go to the settings, where you can start configuring your system. So you have a lot of choices here, indeed, but on the left, this is where you can configure the various elements that make up your system. Generally speaking, it makes sense to explore them in that order. So let's start with things, aka the physical layer. This is what binding add-ons provides as an abstraction for connection to some device or some service. So we'll go ahead and add our first one. We'll try to add a broker, an MQTT broker. So here I'll choose my binding. I chose my binding actually. I selected MQTT broker. I'll give it a name, or an ID, sorry. So, broker, I fill in the details. I actually have an alias for it. And I create my broker, and poof, it's online, so it's working well. And then I notice here that I now have an inbox button now. The inbox is where the auto-discovered stuff appears. Here, since we added the broker, the things that follow certain convention of MQTT topics will be auto-detected, and therefore they will appear here. You have the choice to accept them, or ignore them, or simply remove them. So I'll add this linky thing. It's a quote-unquote smart meter that the power company here forces us to have. So I'll name it electricity meter. And let's add this Me Flora as well. That's the plant sensor I told you about. It's actually named Power Care. And the rest is actually not important. So, sorry. It is this button. So I can select all those and mark them as ignored. So they will get out of my view. Next, we can add, okay, so this is all working, right? Next, we can add a thing manually, for instance, a heat pump. So this binding actually offers some simulator devices. So we use, for instance, this one. We call it pump. I'll reduce this maybe. And we create the fake pump. So now we have some things that are apparently working, but we don't know that for sure yet until we've linked them and inserted them into the functional layer. So let's switch over to the functional side. This is traditionally represented as items in openHAB, and that's very important. It still is. But now you have a system of semantic tags to help give more meaning to what an item actually represents. With properly tagged items, you will build a tree-like structure that we call the model. So on that model page, the first thing we will want to do is add a tree of location. Now, how complex your tree is going to be depends on what your home is like. If it's a one-bedroom studio, you probably won't need much location, a few rooms, and that's all. But if it's like a castle or a private island, you might need something more involved. So let's take the average example of your typical house with a few stories and a garden. So first, I'll create a group item for the ground floor. I give it a name, I give it a label, maybe an icon, and then I'll select the appropriate semantic class, which will be ground floor here. So now we have our first location, our first item. I could add room to that floor like this. So the new location will be under the ground floor. I could add another floor at the root level. I'm not gonna do that. So instead, I have conveniently prepared a few items with the syntax that some of you or most of you probably know. And I'm going to copy that and go to the developer tools here, and I'll add those items in bulk to the database with this feature, add item from external definition. So you'll notice the semantic tags here, and that's what will actually fill up your model with a tree of location. So we'll add all those. And with that in place, we should have now a proper model and with a floor and rooms and so on. So what I want to do now is add things from the physical layer to the functional layer, that is the model, in the form of equipment endpoints. Those are simply other class of semantic classes and tags for items. And we don't have much time to talk about these properly now, but let's say it's the counterpart of the things and the channels of the physical layer, but on the functional layer. So you can map them one for one to things and channels, which some feature in the UI will help you to do. Or you can deviate, and there are cases where it will make sense. It's your choice and depends on the situation. So first, I had the plan sensor from before, which is in the kitchen. So I'll select kitchen, and I'll choose create equipment from thing. And here I will simply pick my floor thing. I can complete the first item, which will be a group for the equipment. So for example, I can give it an icon. I can give it an equipment class like sensor. And below that, I have the list of channel that this thing has. So I can select or not select them and complete the details on the items that will be created and linked. So for instance, I don't really need the battery. I don't really need the connectivity. I do need the lights. So I will simply add. I can add a dimension for the light. It will be illuminance. I can give an icon as always, and I will say that this is a measurement related to the property light. We'll see what it does later. Same thing for this one. Correct the label. This is actually a percentage, so I can give it the dimensionless option. Moisture is similar to humidity, so we can say it's humidity. So it will be, in this case, a measurement of humidity. And finally, the temperature, same thing, will be a number, temperature, icon, and the semantic classification, measurement, and temperature. I do realize this seems a little tedious, and we'll make some improvements to that process in due time, but apart from the name, everything that is configured here can be adjusted afterwards. So you just have an opportunity to change names, and all the rest can be done later if you wish. So I'll add this to the model, and there we have it. You have our floor care, and under those we have the points, and we can already see some values. So that's great. Now I have the heat pump, which will be in the basement. So I'll select the basement, and I'll do the same process. You select the parent, you select the thing, you change the name because this is ugly. Label is heat pump, category is pump, and the semantic class will be, for instance, HVAC. So this thing has a lot of channels, and if you check this show advanced, you see that it has actually a lot of and lots of channels. So we certainly don't want to add them all. So if you click on select all here, it will not select all channels. It will only select those that are currently displayed. So if you just select those, you will only have those ones that are currently checked. So same thing, obviously I'm not gonna do that, but I'll do it for the first one. We have temperature, and measurement. You don't have to do that, obviously. So you just add it to the model. Okay, that's great. We have all this. Last thing I wanted to add is the electricity meter, which will be in the corridor. So again, select it. This is fine. The energy, and this will be a power outlet. Not really, but it's fine. Okay, so all this will be measurements of energy. This will be a measurement of what is it again? Yeah, it's current, and this is a measurement of power, and we add this as well. Actually, let me get back to the thing view for a minute, because I want to show you how to add HTTP thing with a channel completely manually. So let's take the example of our community forum. You can go to that address, so you know the domain, and you do a /about.json, you will see that. For this example, we'll want to extract these values from the JSON. You can note how they are deep down an about object, then a stats object. So how would you get this data, namely the topic count, the post count, user count, into openHAB? I'll show you that right now. So we'll create a thing from the HTTP binding. We use form as ID and form. Then, okay, I've done it before, obviously. So we select the base URL, create the thing, and now we can go to the details, and we see that we have an empty channel list, and we need to create some. So I'll create the third channel. I'll call it topic count, topics. It's a number, so I select the right channel type, and then I need to extract from the complete JSON object the actual value. So if you remember, this was, I use the JSON path transformation, and need to the JSON path query to extract exactly what we are talking about. This is a query. We create the channel. For the other channel, I'll use the code view actually, which is there. So this is a YAML representation of the thing, of part of it. It's great for especially duplicating stuff using copy paste. You'll notice how I can configure the parameters here. So what I just did is hit Control space on my keyboard, and you can add some new parameters if you want here. I can also create new channels. So if we had this, and this would be the posts. And configuration, just copy this and just change what I need, which is this. And I also have the number of users in the community. This is user count, level users, and transformation is user count. So we can save here with the keyboard. If you go back here, we now have our channels ready. So I'll just add it to the model with this button. You remember that for the other things, I did it from the model page. You can also do it from the thing itself. In that case, you will have to pick the parent with this dialog, but not pick the thing, obviously, because you add it from the same page. So this is fine. We can say that it's a web service. You can select all. This is looking good. So we'll have to demo it. And hopefully, yes, this works. So we have all the info from the JSON over HTTP extracted and put it into those items. So now we have a model with some location, some equipment, some points. So let's go make a stop for a little while on the home page and check the tabs that we mentioned earlier. So here we can see that they are not empty anymore. And the card that you see are different perspectives on your model. You can see everything that's in location, or all the equipment in the HVAC category, for instance. We will have the heat pump and all the points. You have a consolidated view of points related to a certain property. So if you have a lot of temperatures, you will see them here too. You can, with that button, you can hide some cards that you don't need. For instance, you don't want your kids to mess with the heat pump, so we can maybe uncheck this, and then you see that you don't have the HVAC type of equipment in those cards. You can also see in the locations that it's figured some information on its own, and it's displaying in it as little badges. That's because of the semantic tags that we apply in the item. Now it really has a clue what an item really represents. And last, but this on page, since we installed Habot, we also have this little text box here, and you can ask it questions or things to do, and it should at least, okay, it can answer you based on your model again. By the way, you can simply give the label like floor care, and you get the info as well. That's very handy sometimes. I want to show you the speech option because I'm using the microphone to talk to you, so I don't believe it will work. Now, before we move on, I'll introduce you to a recent feature that admins will likely appreciate, and that's the developer sidebar. So you go to developer tools and activate it from there. You see the option right away. And what does it do? Let's say you're in the middle of configuring your system, which involves a lot of going back and forth and navigating around and so on. This sidebar is very convenient in this situation. It will stay there when you are navigating, so you can go to other pages and it will stay on. And there are 4 tabs on it and a search box. The first tab is for pinning elements, those you're working with at the moment. You can pick items from the model or search. even rules and pages and pin them to the sidebar so you have an easy access to them. The second tab is an event monitor. You can filter topics, yeah, or not. Click the button and see the events on the event bus in real time. So you can resize this, and you see all the events that are arriving on the bus. The third tab is about expressions and code. You can test client-side expressions that you can put in widget. I don't know if you have time for that, but see it later. So you can test your expressions here. You can have a scratch pad, which is a rule actually, more exactly a script where you can run code on the server. So if you click here, you click the language. Here you have those installed by default. So ECMAScript, it is JavaScript, and the DSL rule language that you know from openHAB 2. By the way, there's a category of add-ons which will contain more language that you can install. If you go to settings here, yeah, it's settings. You go to automation under add-ons. Click the plus button. Right now there are not that many add-ons there on the GUI for now, but there are more on the way. And you likely won't simply find new languages in that category. You will find maybe libraries and modules and that sort of stuff as well. So, in fact, let's start with it. Shouldn't be long. Okay. So you see that it's installed. So now, if you open the Sketchpad again, you will have the option of coding in Groovy. But let's try to make a rule now. So the rule editing has been vastly improved in the UI, and now it's a viable option to write your rules in it. As always, it doesn't mean that you have to. If you were using one of the various file-based approaches in OH2, they are not deprecated, so you can continue to use them if you prefer. In our case, notice how I created two positions here in the model from before, representing two people abstract maybe by their phone, for example. So let's simulate change in this position without actually linking them to things with a rule. So we'll create a rule. You can also create most elements from this last tab of the sidebar. So you can choose create rule here. It's the same. So we'll give an ID, update position. So we have here triggers, the when, we have actions, the then, we have conditions, the if. The rule doesn't have to have triggers or actions, but if you don't have actions, the rule doesn't do anything. So it's better to have at least one. But triggers and conditions are optional. You can actually run your rule manually from a widget. For instance, setting scene. You might not need any scripting whatsoever for scenes. Just send some commands to a series of items. Yeah, some commands. and add the button to the home page, which will run that rule, and that way you only have actions. But in most cases, you will have the rule reacting to some event with a trigger. So these triggers are usually related to some item changing or are time related, but you can and will get more as you add more bindings, for instance. And same for condition. You have things related to items, things for ephemeris, things related to scripts, and so on. Let's not add a trigger right now, and let's do a little bit of scripting. So we'll have the script rule. We'll do a JavaScript rule. So leave the language to ECMAScript here. And we could write our script directly, but I'll show you something else. So to access a better editor, we have to save the rule first. So we save the rule. And now the rule is created, but it is in error because there is a script action, but no script. So by the way, like for things, you have a YAML representation of your rule in the code tab. So you also have some auto-completion. So if you want to add some module, you can simply trigger the auto-completion. And it will help with your rule that when you have to duplicate some things, it's very nice. So now you can notice this little icon here. And if you click on it, it will open the better script editor. So in there, you can simply type your code. For instance, events, choose send command here, and braces, and code, and try the auto-completion. And since it expects an item here, you can simply choose one, so on and so forth. Right? But let's erase that and try something else again. So if you're not too comfortable with coding in JavaScript, or if you want to have fun with your children, why not? You can have the Blockly option when your writing code is in JavaScript. So let's try it. When you don't have any code, you simply get this blank surface. And what we'll do is assemble blocks together to build a program. So this is basically for the interacting with items now. So it's not very powerful, but I believe it covers a lot of use cases already. So first, we will maybe pin the items that we are working on. So I'll search for position, and I'll pin that and that, and maybe the positions as well, the rule. And we'll try to build some rule. So we're gonna need a list here of 2 elements. So we remove one. Then we want to make an addition, some math. We copy that, and we want to add 52 to a random function. That will be our latitude. And now we want to copy this and add 13, the longitude. Now we want to make a text. We want to join that list. So we want to make a text from the list. And now we want to update the 2 items, so make another list. So again, only 2 elements. And we create a text block here. That you can say Alice pause here. Stop. Now we want a for each loop for this list. So connect this. We'll create a new variable. We'll call it bus. And we want to set bus to that stuff. And finally, this is the most crucial part, the openHAB part actually. We'll add this and send or post an update of of bus to I. And then we save. So you see that the rule is now green. With that button, you can actually see the code that was generated by Buckley. You cannot edit it because it's a one-way street. And let's test our rule now. So if you click here or Control R, it will run the rule, and yeah, you see here the items are updated. You can run it a few times and see that it's actually changing. So let's go back to the rule now and add a trigger. We want the rule to run every 5 seconds. So we'll add a cron trigger, and we'll build our cron expression with this editor dialog. By default, it's 8 o'clock in the morning every day. So let's change that. We set it to every 5 seconds of every minute of every hour. So we are done. The label here says every 5 seconds, so we're good. We save. And now we can check that the rule is actually running every 5 seconds. Yes. I hope. Okay, so we covered a lot already. The last thing I want to show you are pages. And it's really a brave new world, to be honest. I could do a day-long session of this alone. We'll just scratch the surface today. So I'll open the pages. I'll click this button. So there are different kinds of pages. I put the sitemaps as a kind of pages, even though it's quite different. You know what sitemaps are. If you're using openHAB at all, chances are you have some. These are the same as in previous version. The difference is that you cannot design them in the UI if you prefer to be able to edit them on your phone or whatever. So not every feature is supported yet. So if you have to have conditional visibility or colors, adjust it to 5 for now. But let's say I want to add a frame. I want to add maybe a chart here. I'll select some item. Maybe, no, it's a chart, so this one. H. Now add maybe a map. This is a location. This is okay. You can put an icon. Here in the code view, you actually have not YAML this time, but you have the sitemap settings. If you want to edit like you did before, you can largely just save it. What is important to know is that for the moment they are still viewed only with the dedicated basic UI or the mobile apps. So not this UI, and you can find basic UI. Let me move that. You can find basic UI in this little drawer. So if you have basic UI, this is the sitemap that I just created. Now, for another type of page are maps and floor plans. So we have locations, so we can create a map. Yeah. Can add some markers. This. Yeah, this one. I'll use this item. Done. I'll create up. Bob. Here. And these pages are only for this main UI. You know it because there's a run mode here that you can switch, and you'll see the page as it would be in run mode. We also have floor plans. I'll show it very quickly. This is a plan. I think I still have here an example. Just copy that. Paste it here. Check this. So let's switch to run. Okay, this works. So from there we can add a marker. We can put it here. We can configure it. That will be the plant. And I want to show this. With this icon. And most of the widgets in pages that are clickable or that you can tap with your touchscreen, you will have actions. So actions, it allows you to select what will be done when you click or tap the widget. For instance, group detail here, and we choose the item to be our care. And we save. What you can do for pages like this is under this sidebar and visibility thing, you have a show sidebar toggle. And if you activate this, you can now see your page here on the left side. And here, when you click on this little marker, you will have the action performed. So that's it for maps and floor plans. Let's switch to maybe charts. So the charts are one of the major new features of the UI, combined with the fact that openHAB now has persistence enabled by default with a default service, default configuration. So you can graph the history of many items directly without configuring anything. You have different ways of getting a chart. First, you have the chart pages here. Yeah. Or you can launch what's called the analyzer window for many places. For instance, from discards, you can open one. You can click here, and then you'll have the charts with the data from the last 20 minutes or so. You can actually go to this view. This is not good, so I'll open up the controls and I'll go to ranges, and I will set the maximum here, maybe 30. Okay, this is better. So you can also add some series. So for instance, add this. You can make it an area, and you'll notice that it created some axes, and it automatically selected the right one based on what it thinks it's the unit of your item. So when you're happy with that, you can, if you want, save it. Chart. And it will actually save it as a chart page here. So you will have the whole thing configured for you. You can run it, and it's actually the same chart. You can adjust some things if you want. So if you want to add a grid, I'll do it very quickly. You can say that this means 60% up, and this is 60% bottom. And now, hopefully, you will have two charts. Maybe if I had a series, it would be better. So I had one very quickly. This one. Okay, so you have your double chart here. What next? Yes, last but not least, you have what are called the layout pages. So they are arguably the most complex of them all. They are very hard to grasp, but some folks on the forum have already figured that out, mostly. And they are starting to build very nice thing. I'm very pleased. So I hope we'll get some nice introduction documents in the near future. Before we talk about pages or layouts, I want to talk about widgets. So there are several classes of widgets. You have your system library, which are basic controls. You have the standard library, which are the basic control, but in a card. I'm simplifying. You have the list items, and you have the cells. And on top of that, you have personal widgets. Those are widgets that you can code yourself or take from the community and adapt. Then you have what we call the default representations of items. So for instance, you have this flower care, and what you can see here is the default standalone widget for this item. It's not very fancy. Null is the current state of the group, and you can click on it, and it will show you the members. But I have actually prepared some widget here, which is just for this sensor, actually. I'm not going to go into detail. It is way out of scope for today. But you'll notice the item parameter here, this one. So if we can copy that and go to the developer tools and go to widgets, we can actually create one widget and it is just, I wanted to paste, of course. So I'll paste and replace old stuff. And now I have this more fancy widget. And if I want to test it, I will set the parameters here, maybe to kitchen. And I will select the group. And boom, we have all the info that are taken from the item with the same prefix. So back to the model. We want to change the default widget that we see here. So we had some metadata. By the way, you see that you have a lot of things that you can change with this metadata. And we'll want to change the default standalone widgets. So what we could do is, oh, I don't have it. Maybe I didn't save. Yeah, probably. Okay, now it's saved. So back to this. We want to add the metadata for the default standalone widget. So I can choose the standard library controls like this, or this, or this. But for this item, what I want is actually my personal widget. We can see that the item is automatically populated. We can, however, change the others. There you go. And we save. And now we can see that the default widget for this item would be this very nice one. So now let's get back to our layout pages. So as it happens, you already have one, and that's the overview page. So the overview page is what's displayed on the first tab of the home page with the chat box that you remember. And you can add anything to the overview page, but bear in mind that since it's the first things you see, try to be smart about what you really want in there. Probably stuff that you really need, like conditional alarms or currently playing music or whatnot. This is also could be simply a menu that will bring you to the other pages with actions. So basically, layout pages, they allow you to display widgets like the ones we just saw, and make them adapt where they are to the size of the screen, what we call responsive. So we have several options for defining this. You can add blocks, as many as you want. And with block, you have a lot of control, and you can actually also end the page with a masonry layout, which will try to put widgets where it can. It's a bit simpler, but maybe not always as you want. So let's just add blocks for now. If you create a block, then you have the choice of creating a row and some columns. So let's have a row, so columns. Yeah. You can also create a container for cells. Yeah. The cells are fixed width, so easier to manage. So let me put them here to the top. When you want to add a widget, you will get a menu where you can choose the type of widget that you want, including the personal one. Be careful because it's not a cell, so it won't work well here. And you also have this add from model option. What this will do is add let you pick items from the model and add what is currently the default widget for that type. So for instance, if we wanted to have these three, we can add them, and it will be the default widget for those items. Same thing if you add a list card, maybe here in that column. And then if you click here, you will have actually not cells or not cards, but list items. And if I add them from the model, for instance this, I will have some lists. If I run, this is what it looks like currently. I'll also add the floor care here. So add from model, floor care, and obviously it adds the default widget. Finally, I can add some card here. I can configure it. So it's a map. And as an option, I'll say open pop-up, and I'll choose my map page. I can put maybe this to make it bigger. Yeah, this nicely done. So now if I save and I go to the home page, this is what I'll see. So we have those nice cells. We have this card, and when we click on the card, you will see the page, the map page from before in a pop-up. So I could go on and on and on about all the possibilities here and potential that you have on offer. But for now, I believe we've seen enough for today. And so with that, I believe I can stop here now and maybe answer a few questions.
Awesome. Thank you, Yannick. We could have gone for probably another 3 hours just talking about all of the features and pages, and just to let people know, that's secretly, that's one of my favorite parts about it, is the ability to build these just amazing UIs within the interface is just incredible. And we didn't even touch the standard widget set inside of that in terms of everything that it comes with, and also the ability to import widgets. I mean, it's fantastic. So I encourage everybody to give this a try, but be warned, it's a good way to kill a weekend because you'll find yourself just creating more and more UIs. If you like HAB panel, you're going to especially love the page builder here. It's really fantastic. I will bring up a question. Let me go through the chat here. There was definitely one very popular question here around logging that I wanted to get into. I was going to post it here, but a lot of people, and I know this is not a feature we may have already, but a lot of people were voting for the ability to view the openHAB logs, to tail the logs within the UI. And I don't know if that's something maybe you've thought about, but it seems to be a really popular topic on the comments here.
Yes, I know, but what you have to know is that the API, the UI actually is dependent on what we have as an API. So first we'll need to have the logs maybe as SSE in the API, and then we can do something.
Yep, gotcha. And then I think in terms of time, maybe I'll do, let me see if there's one more question here. I think there was a couple questions about will openHAB 2.5 be compatible with 3 in terms of upgrade paths and UIs? Do you want to just give that a quick answer? It's maybe a little outside of your scope, but will people's current UIs that they have currently continue to work in 3.0?
Okay, about HAB panel, you still can migrate. It's not really easy right now, but you can do it. Maybe I'll show or I'll link to the forum post that where I explain how to do it, because it's not that trivial, but it's possible.
Okay.
About the sitemaps, as I said, if you have sitemaps in a file, they will continue to work. So you are covered for sitemaps, and that's it.
Oh, great. And I will actually, there's one good question here, which I wasn't, just got asked, and I was actually thinking about myself. Let me show this one. So my class, what's the best way to design and exchange best practice widgets? So there is much like HAB panel, a way to import widgets, and I think that's probably a good one, as there's going to be a lot of widget swapping going on. Yeah,
not yet, but as you remember, Kai has talked about a replacement for the marketplace, and that's that would be a way to share those kind of widgets, maybe.
Agreed.
So we'll have maybe modules or rule stuff, and also UI widgets in a marketplace like this.
Fantastic. And as someone else pointed out, the community forum is already a great place for people to start swapping the widgets as YAML files, and again, that's also very addictive. You start tweaking those, and it's amazing. So, all right, Yannick, thank you very much. I appreciate it. So, in the sake of moving on here, I'm going to go ahead and bring in Marcus. So let me just do this, and then I'm going to bring in. All right, Marcus, I'm going to hand this off to you. You can talk a little bit about openHAB.
Yeah, thank you. Seasonal greetings to all of you. I guess you're as anxious to try out the new great UI, so I'll keep this short. Let's have a quickie on openHAB. So I actually, well, you might know me, I'm a long-term forum inventory, I should say. And about a year ago, I took over openHAB maintainership. And I am also about to start my business on top of openHAB. So now that I'm an architect, you can even pay me for screwing up things. But okay, granted, I think I need to improve on my marketing skills there. So what did we do? We had some maintainership changes. Thomas and who started the project, and Elias who took over, they are unfortunately no longer active. But I'm happy that Ethan Dye joined the team. He started right away with actually refactoring all of the code. I think that's quite not a thing you would normally do when you're the new guy in town. And this really already paid off in terms of quality. So the idea, the vision of openHAB is still, well, hassle-free user experience, as Thomas has put this slogan. I've been cursing him a number of times for inventing that because it's a lot of hassle, in fact, at least to me. But well, we're trying. It's Raspberry first, so it's an OS, an image you can deploy to the line of Raspberry Pis, but it's unlike Dan said in his intro, it's also supposed to work on x86 on Debian. So if you've got a NUC or a data center class server rack in your basement, you can still use it. No Docker ever, because if you know how to do Docker, well, then you're the type of IT guy that doesn't probably need the help to get stuff up and running quickly. The idea is, well, it's a simple, cheap, low entry cost box you can put into your house, and that is working totally independent of any internet, any cloud stuff. It's about reliability of your home, isn't it? So we had, when I took over maintainership, we had at the beginning a starting point where this was a lot of work doing testing, essentially manual testing steps. So it was that sort of cycle. Less a point missing, which is I had to run the stairs every time. This box, it's located 2 stairs down in the basement, so this became a real sports event to me. And some days you have to buy another set of SD cards, but anyway, that was the starting point. So what I did first was to introduce continuous integration pipeline. This was what I took on when I joined development. So I was now you can deploy this in the cloud, but just for test purposes. So I was right away violating the principles from the last slide, not to use any Docker, but it's just for testing purposes. We also added BATS is a bash test automation framework. So all of the stuff that gets added or has been added, such as third-party tools, they are also well tested. So it's well, more reliable or more probable that it'll install smoothly on your system as well, because that's always the problem, to reproduce things. If someone comes up with an error, it's hard to reproduce that. So beyond that, we improved our code management. Everything is being linted. We got a code style guide now, and as I already mentioned, Ethan took on refactoring all of the code. Before it was essentially an interactive tool, the openHAB config. Now we turned that, we broadened that, so it's getting more and more automated as well. So it's got an unattended mode as well, which has been there from the beginning, which is what gets executed when you install or when you boot up actually the image. But now we extended that to work with all the routines on all the parts to get, well, to have it run automatically as well. Yeah, we took on the open bugs. In the beginning, there were about, when I took over, it was about 130 open issues. Okay, half of those could be closed right away because they were obsoleted, but the other half was actually, well, quite a challenge. So we had a quality focus. That means in the first place, I was trying to, well, right size some expectations. What's hardware that you can expect this to run on? What's OSs? And then we added those that are, well, popular for good reasons, or maybe popular in some niche markets like the CM modules, the compute models you might want to use, and if you're using or aiming to use openHAB in some industrial application. And we stripped down a little bit on the broadness of support. So it's not really no more non-Pi ARM machines. And Ubuntu, well, it's a Debian, but officially it's not supported. You can run it, the core part runs, but the third-party tools, some of them don't, such as Mosquito or HomeGear. Well, it's a bit of fiddling. You can get it to work, but it's not working out of the box there. So yes, see, I'm selling you a loss for a benefit. So well, I already learned something in terms of marketing. So you get an up-to-date image now based on latest Raspberry Pi OS. All the packages were updated. We had the complete refactoring of the code. We got now a master and a stable branch, so similar to what you know from the openHAB distribution. Before it was always like master is the only code, and whenever I changed anything in there, it became effectively effective right away on your box, or the next time you started openHAB config on your box. So that we had to put in some buffer, so not every bug of mine immediately gets distributed to all of you. Documentation was improved, and all of that it took some month actually to do that, but it paid off. We could get the open issues down to about 10, or well, found some more actually. We're at 50 now maybe, but it really paid off. It's more of open ideas rather than bugs, which are still there. That was when we finally had the opportunity to take on new features, and this is what you now have in current version 1.6.1. First of all, we improved on automation. As I said, it used to be an interactive thing in the beginning, but now the idea is to roll out, to deploy boxes that you can maybe use in some remote location. So if you want to say run an instance in your parents' home, we already heard about the openHAB binding to bind to some remote instance. So if you want to use that and you want to install on that remote site, it's difficult if you're not on site and can change any of the settings there. So the initial part to get this up and running, there have been made quite some improvements on that. So you can load your SSH key, you can make it connect to a VPN, and that's the next point. Is there's actually 2 VPN options in there now. WireGuard, which is sort of one-on-one tunnel, and even more exciting is to me at least is the Tailscale stuff. That's another open source software, but it's also a service. The guys who built this turned that into some company they run now. But it's open source software still. It's also based on WireGuard, but it's taking care of all the framework to handle and to store all of the configurations in a really smooth way. And you can run multiple remote locations. You can the nice thing it does, it automatically takes care of any firewall in the way, so it's not opening the ports. You don't have to do that yourself on your router. It's automatically taking care of all of that. Sadly, that's a business they run, but it's if you don't run a business like I do, if you only use it in private for your own private use, it's free of charge. So it's a nice thing to install. openHAB 3 support, of course. Yeah. I tried my best to make it a smooth upgrade experience. Possibly even a downgrade experience. I hope you don't need it. The upgrading only is possible because of the config upgrading. There's no downgrade of that. But the software up and downgrade forth and back should be possible now from within openHAB. Auto backup, it's sort of, well, it's about reliability to run your home, right? Even more so if it's a business you do. And the auto backup, it's essentially SD mirroring. So you since most or many run Raspberries, and you know the famous SD wear out, so you're in danger of your system breaking down at any time. So in the first place, there's that RAM that is sort of mitigating that a little bit, but you can still have your card break or your system break. So now you can mirror effectively your SD card, and if any of your hardware breaks down, you can just plug that out or plug the copy into some new system and get back running fast. Latest edition was a hotspot, so if you don't have Ethernet and you want to jumpstart your system, well, it's a chicken and egg problem. So now you have a hotspot that you can use to do the first time configuration of the Wi-Fi interface. Some outlook. Okay, we plan to do some config management in inside openHAB. Not sure yet how that's going to look like. That's it for the most part. Any qualified feedback I would like to ask you to contribute on the forum or on GitHub, because it's important to know what the problems actually are. It's hard to find out myself, and well, I'm sort of tired of running the stairs every time there's someone to say, oh, it didn't work for me, and to reproduce that, it's difficult. So please, any well, qualified feedback, that's appreciated. So that's about it.
Awesome. Thank you, Marcus, so much. And boy, I actually didn't know about WireGuard and some of the new tools, so that's super awesome. Those are, see, I learned something new too. Well, so if you've got any questions, please ask them now. I think a couple of questions generally are around the migration of 2.5 to 3 on Raspbian. Is there an upgrade guide or a how-to document somewhere that people can read about that?
Oh, well, we are still busy figuring that out. There is currently there is a post on the forum from Ben who describes how to manually do the upgrade in a way that it also migrates the config. There is no downgrading, although you can, of course, take backups. And as I said, it's integrated in openHAB to do this, to run this. But we're still figuring out the issues that might still be in there. So it's there is no migration tutorial yet. We're actually still looking for someone to write that down. We're all
you hear that? If anybody out there wants to volunteer in documentation, I think that's generally would be welcome across any of these projects.
Yeah, you don't have to know this stuff. You can get the info from us.
That's right. People are asking how they can help. Well, documentation is probably one of the biggest areas we could use help in, for sure. And there's a lot of it. Last thing I'll ask, last question, Marcus, is a few people asked, are there any, does this run on all lines of Raspberry Pi? Is it going to run on the new 4? Obviously, it runs on the Raspberry Pi 3. What's that?
All of them, yes.
All of them. Fantastic. All right.
No non-ARM ones, okay? So if you're into some Odroid or whatever, sorry.
Yeah. Yep. Absolutely. All right. Well, thank you very much, Marcus. Next up, I'm going to bring in Christoph here. So, Christoph, I'm going to bring in you, and you're going to talk about Bayesian sensor aggregation. So I will kick it off to you.
Yes, I will. Hope you can hear me. Hello. My name is Christoph, and most of you will know me as part of the openHAB maintainer team for openHAB core and add-ons and distribution too. And today I would like to talk about Bayesian sensor aggregation, which is an idea spinning around in my head for a long time, but I didn't have the time to sit down and implement it. So this virtual meetup was a very good point for me to do it. First of all, I will tell you what's my motivation to do this. After that, I will give you a short introduction in the Bayesian theorem and statistics in a nutshell. In the theory part, I will tell you how I mapped it to openHAB terminology and show you a rule how you can calculate probabilities. And after that, I will construct a small example, a Bayesian sleep sensor. And after that, you will see a short live demo. All right. My motivation to look into this sensor aggregation was because I want to have greater reliability in my sensor data. I guess you all know the phrase, do not trust in one sensor at all. So some of you will use more than one sensor for a particular reason. For example, if you like to do presence detection, then you don't want to have only one sensor. You try to combine a lot of different sensors. But there are some downsides when you use multiple sensors. For example, there may be insufficient measurement frequencies, or the data is not very appropriate. You need to tweak it by an offset. Or you have an unstable connection, false positives, false negatives, and other stuff. openHAB ships a lot of basic methods to combine sensors in group functions and group function aggregation. But there's another reason why I wanted to use Bayes calculation. I wanted to try to detect some events which are not really measurable, like sleeping or having a shower and something else. And that's why I need some kind of weighted sensor data aggregation. And my favorite, and not only my favorite, a very good tool for it is the Bayes theorem. So after my talk, you will know what the Bayes theorem is and how to work through the calculation on a real scenario. I strike that out, but there will be a slide in my presentation which you can research on your own later after the talk, which shows a basic example how to use the math based on current Corona stats. You will also know what the terms in the calculation mean and what's the intuition behind them. And you will know how the Bayes theorem could be used in openHAB. Additionally, you will know some insights of the Bayes theorem at all. What is it? It's a statistical theory, a formula to calculate conditional probabilities. You also can say Bayes rule or Bayes law. And this rule is widely used in field of machine learning. There are different approaches, neural network or Bayesian networks, which use this kind of math. The formula itself was named after Reverend Thomas Bayes, an English statistician and philosopher. Okay, let's have a look at the formula itself. This is the simple form of the Bayes theorem. I don't know how many of you are familiar with the notation, so I'll give you a short introduction into basic statistic terms. First of all, we are talking about probabilities. They are notated like PA in brackets and called marginal probabilities of observing events A and B. Each event, especially if it's binary based, it has a complement and can be calculated by 1 minus the probability of the real event. The conditional probability of an event occurring is notated by PA pipe B, and the meaning is that we have event A occurring given the observation B. And similar to the formula, the rule above, we can calculate its complement by 1 minus the probability. There also is a third probability called the joint probability. It's often used in tree diagrams. And I mention it here because we later will use it to replace and use it in our formula. Okay, back to the simple form. What do we have here? We have P of A, the probability of A, which is called the prior probability. We have the conditional probability PAB, which is called posterior probability, and which will be the result. That's what we want to calculate. We have likelihood. It's the opposite, and it's the degree of belief in event B, given that the proposition or observation A is true. And we have P of B, which is the evidence. Most of the time, we do not have access to the evidence directly. So we have to replace it by a second formula, and that's the sum of the joint events. And additionally, there's a hidden slide, which you can have a look at later, where is shown how the joint probability is calculated based on the tree diagrams. Okay, now what do we need to calculate the posterior probability? We need the prior probability. We have to define it. We can calculate the complement. We need the likelihood of an event. And optionally, we need the likelihood if we need the likelihood in an event B if A is not given. All right, the theory. How will I map all this stuff into openHAB? First of all, we need a rule for doing the math, which calculates our probability. We need several items, including metadata for the items, which will be used in the rule. We need a proxy switch, which represents the target item and the final sensor state. We need a group to collect all items of the observation. So we we can iterate over them and use their metadata for the calculation. And we need, of course, all the different items which represent our observations. Now you can see the pseudocode for my rule. In the upper page, you can see the Bayesian theorem itself, which calculates the numerator, denominator, and returns the result. If we want to observe different sensor states, then we can change the calculation and use the prior calculate, consider the first observation and use the result of that to calculate a second, and so on. After that, we check against a threshold and set the state for our sensor, target state. Now let's have a look at the group. Later, I will show, or you see it at the bottom of the page, there is a group. Oh, I'm sorry. There is a group definition, and it has metadata namespace Bayesian. The value of the metadata namespace is the name of the target item, the sensor. For my example, it's proxy switch. We have a prior, the P of A, so the overall probability at any point in time of the event being true. This is something we have to estimate before. And we have the threshold. Oh, I just saw it. I forgot it in the example, and I will add it later. I'm sorry. And we have a state given true and state given false, which are the final stage to send to the item. Why did I define them here? Because you not only can use a proxy switch, you can use other item types too, like contacts, and then we want to have other states, or you maybe want to invert them. And then for each observation, we define an item. We use namespace Bayesian again. We define a value, which is the signal for when this probability should be considered in the calculation. So when the item has this state, then it will be considered. We have to define the prop given true configuration. This is the probability of the observed state is occurring given the event is true, and we optionally can define the prop given false. Okay, that was a lot of theory. So now I like to map it to an example. And as I already said, I like to detect my sleep. And I created a Bayesian binary sleep sensor. I called it binary because I only considered switches in my example. The prior of the sleep sensor is, let's say, 50%. So half the time I'm at home, I'm sleeping half the time I'm at home. I guess it was before Corona. We define a threshold, and that should indicate how sure we should be before guessing the sensor to become true. And we say it's 85%. So we have to be pretty sure. Let's add some observations. The first one is a presence sensor. So I'm at home or not. The likelihood that I'm at home if I'm sleeping should be 99%. So obviously, I need to be at home to go to bed. But sometimes it's not the case. And most of the time, or half the time I'm at home, I'm not asleep. So we set it to 50%. The second observation is the time of day. So after sunset or when it is night, I'm sleeping, but sometimes in winter, it's getting dark earlier. So it's not always true that it is dark outside when I'm sleeping. The second observations are my lights. So when I'm sleeping, usually my lights are turned off. So we say it's 90%. And but I maybe want to watch a movie, and my lights are turned off for that reason too. So we have a small probability that the lights are off when I'm not sleeping. The last observation is the do not disturb mode of my smartphone. And I always mute my phone when I go to bed. But sometimes I muted it, like in this talk, I muted it too. So it's not always an indication for me to sleep. Okay, now I will show you the live demo. Okay. So I uploaded items, a Python rule, and a sitemap to GIST. I will share the link later. And I created a small sitemap. At the top of the sitemap, there's the Bayesian sleep sensor. I added an additional proxy item which shows the resulting probability if I'm sleeping or not. And at the bottom of the page, there are the 4 observations. So at the beginning, I'm not at home. It's in the mid of the day. My lights are turned off and my phone is not muted. So additionally, I have to say I added a small rule when to turn on my light when it's getting night. After work, I come at home and watch the percentage at the top of the page. It will change right now. I'm coming home, so it's getting more likely that I fell asleep, but it doesn't hit the threshold, so the button still is off. After that, when it's getting night, you see my lights turned on and I'm not asleep. If the lights go out, I suddenly, yes, the sensor detects that I'm sleeping. But in a second, there may be a situation where I'm watching TV or we are watching TV and I want to go bed and sleep a little bit earlier, but my wife still wants to watch TV. The light remain on, but I mute my phone and you can see that I'm sleeping too. So a few last words. This is not a proof of concept. It's a draft and only for now available in my own openHAB environment. But I will share the code and I will open a community post later so everyone of you can discuss and add something or ask question if you like. All right, thanks for the audience.
All right, well, thank you very much for that. And we do have some questions here. Actually, I will show this one. So the question is, why did you use a simple Bayesian approach and not go with a neural network? And I think someone else asked the same question as well.
Yes, that's a very good question. At the beginning of my talk, I already mentioned I had this idea in my head for a couple of weeks or months, but never found the time because I'm focused and on openHAB 3 release. And at the time when Dan announced the virtual meetup, I sit down and wrote the rule and everything else from scratch. So it's just draft. And as I said, not a proof of concept. And I guess it's a first step into machine learning. And I hope it will be very nice if we somehow can integrate in openHAB framework if it's accepted by the community or everyone.
All right, fantastic. Well, thank you very much, Christoph. I'm now going to bring in Patrick. And Patrick's going to talk about innovative input devices for openHAB. Patrick, you are our last presentation, so why don't you you take us home before we wrap up?
Yeah, sure. Then I'll start right away. My topic is innovative input devices for openHAB. We will get to know soon what this means in detail, what devices we will focus on, or I will focus on within this presentation. First, a few words about myself. My name is Patrick Fink. In the community board, my username is pfink. And in the community, I'm mainly active as a binding developer. And also I did the release automation process for openHAB, which thankfully lead to the situation that we have much more releases than in the past, and especially the milestone releases that we can all take advantage of. Yeah. What do I mean with innovative input devices? Yeah, so of course, I have to focus the presentation on some few devices, and maybe I can start a little bit also talking about my motivation looking into input devices. My main motivation is that I was looking for possibilities to control the smart home without a touchscreen and without a voice. Yeah, of course you can make the home smart that it does everything itself, but there are always some let's say controls that you have to do manually. For example, music volume, play pause of music, and so on. So you will always have, like, I think some manual input, and so I was looking for devices without a touchscreen and without a voice. Especially because I don't have the possibility to use much wiring here in my rental apartment. And of course, this applies to many users that you have yeah, complicated. It's often complicated to get wired input devices. That's why I was looking for wireless input devices, which also provide much more flexibility in general. Basically, we can put them everywhere. On my office, we have it even mounted on glass walls. So they have much more flexibility, of course, on the cost of reliability. Some few words why I don't like touch screens, or why I didn't look much into touch screen solutions. So generally, of course, touch screens are energy hungry, especially when they are always on. And yeah, and the main issue I see about touch screens is that they don't give haptical feedback, which means you always have to look at the touch screen to really see whether your input was really, let's say, accepted. Yeah, you have to look at it or get some other feedback, and this is very nice on haptical devices like switches. Yeah, you don't have to look at it. You can use them while you are in a conversation with another guy, and you can just do it besides. You don't have to, let's say, concentrate on it. You can just do it. And also, my impression is that touchscreens are often, not always, but in many cases, are very slow. Many slow interfaces. Yeah, when you put out your smartphone and go open the app and so on, that takes a little bit of time. And also, touchscreens, of course, have usually, not always, but usually a low woman acceptance factor, which should also not be underestimated. Last but not least, they tend to have a shorter product lifecycle and also shorter lifespan. So when you think about touchscreens that you have in your home, you will hardly find one that is older than 5 or 6 years. Usually, you will buy new ones much faster than, for example, switches, buttons, or whatever. And for voice control, you have also one problem. You need silence, and you need probably or potentially interrupt a running human conversation, which is not so nice. And of course, you have also many people who are concerned about let's say the cloud-based voice controls. So I said enough about the other solutions that have their sense but are not sufficient in my point of view. And now we will come to the interesting part. What are the alternatives? And the main alternative that everybody knows, of course, is are wall switches. There are also many wireless wall switches on the market based on different technologies. I don't want to talk too much about wall switches as they are not so, let's say, innovative, but I will have a short part also about batteryless wall switches again, because I think there we have some developments on the market that are interesting. And also, I know batteryless switches very well. I have them in the office and also in my home, so I can compare them to battery operated switches. I think quite good, and show you a little bit of the advantages and disadvantages. So mainly, we will focus on the 4 devices that you see here depicted. We will also see them a little bit live. And let's start with the batteryless wall switches. We will also add some device camera here, so that where we can do the live presentation later on. I will also already put some batteryless wall switch here already onto the camera. But for now, let's talk about the pros and cons of batteryless wall switches. First of them, how do they work? So they don't have any energy reserve or something, or don't have any battery. The energy needed for the wireless radio transmission is basically generated during the button click. So with the kinetic energy of your button click, the energy needed for the wireless radio transmission is generated on the fly, and it's also basically exhausted on the fly, which means all batteryless wall switches, at least the ones I know, they don't have any they don't have any state. Yes, you can't reach them, you can't retrieve the online status or something. So they are only, let's say, on or online as long as they are used, basically. This is, you can see it a little bit, you can see it negative, as you have not so much control or not so much overview. For example, also in openHAB, you don't see always the online status, or you cannot be sure about the online status or whether they are connected or something, because they are not connected. They just do fire and forget communication. And but on rockers, that can also have some advantages. We will see this in the live demo. Of course, batteryless devices have less maintenance effort and cost, especially if you have many devices. Then it will be much help for you, let's say, the maintenance, as you don't have to switch the batteries, you don't have to buy new batteries, and you don't have the trouble that you get run out of battery and then the switch is not working anymore until you change the battery. Yeah, and there's also one disadvantage about that, especially about the fire and forget communication. That means basically, if something goes wrong, if it's some kind of unidirectional communication, you just send your message and you don't know if it has arrived, and you don't have any energy reserved to react if your message did not arrive. You don't have any, let's say, you don't have any second try or something. So that means that some, but not all, of course not all, but some battery operated devices, especially those who have bidirectional communication, who are checking, did my message arrive or not, and which can try again if there was an error or something. Those have, in my experience, a better reliability. And last but not least, batteryless devices are a little bit louder. It's a very small con. I think for me it's not relevant, but of course you need some kinetic energy. They are also a little bit louder when you click them, and they also need a little bit more, let's say, energy for the button press. But I think normally you won't notice that. So maybe I can show you. I think you won't hear it a little bit. That one here is new, quite new model of batteryless switch, which is based on Bluetooth technology. So in general, batteryless switches are quite long on the market already by the company Ocean. I think they were brought on the market on 2002. Our office was built in, I think, 2006 or something, and the batteryless switches from this time are still in operation. At this time, this was a proprietary protocol by Ocean, which is still exists and which is still valid, and there's also an openHAB binding for that. Still can be used. So I wrote here on the slide old and busted. So not really busted. It's still valid and working. But of course, you need the battery release, separate radio transmitter to basically communicate with this proprietary protocol. And what is the new hotness about batteryless wall switches now? So Ocean brought some devices now that are based on Bluetooth and Zigbee. on the market, and yeah, so this means the Zigbee for the Zigbee devices you can even have batteryless wall switches for your Hue bridge, I think, which is a very easy way to integrate batteryless wall switches into your home, especially if you already have the Hue infrastructure. And yeah, personally, I did decide to use the Bluetooth option, and I also did develop a binding for the N-Ocean Bluetooth batteryless wall switches. Yeah, the pull request for that is created, and yeah, I think there are good chances that we get that into the next, or maybe the release after the next release, or one of the next stable releases, get this into the openHAB 3 distribution. Unfortunately, those switches are a little bit not so good available on the consumer market. You have to fight a little bit to get some. Of course, my knowledge is a little bit limited as I'm German on the German market. So I put some hints on the German market here onto the slides. Who's interested can look into the slides after the presentation. And yeah, so what I'd like to show to you basically was the part, what does stateless mean? So on a normal switch, when I push the button down, the button is going down and staying down. Yeah, and stateless means basically he is getting back into the original position. You see already my light here in the background. When you look at my camera, was going out now. So, and this going back to the original position, of course, some battery operated switches can do that as well. Offers some possibilities. For example, we can just now put the light on again. And what we can do now is that we have some, let's say, scenes in the background configured in our openHAB. And when I put now the on button again, I can okay, that did not work. The demo god is not on our side today. Okay, the second try it did work. So yes, you can configure some scenes in the background and click the button again on, and you have like different colors. Yeah, I use it, for example, in my kitchen for switching between the cold light and warm light, basically. Yeah, let's go back to the normal lightning. And yeah, that's what I basically wanted to show about batteryless wall switches, or better to say rockers. And yeah, hope that the binding regarding the Bluetooth switches are finding its way to the stable distribution. I need to get some water. So the next thing that we want to take a look at, or that I'd like to show you, is the flick button. It's a very small device, as you see here on my device screen. So very easy one. As you see on the slides, there are even clips available. Yeah, yes, you can put it onto your jeans or into the jacket or whatever. They are also Bluetooth powered, and yeah, basically they can work via smartphone app. They can work via a proprietary bridge by the manufacturer. But there's also an SDK for Linux. Unfortunately, it does not work with the openHAB Bluetooth binding, at least yet. For that, there would be some reverse engineering necessary. So that does not work yet. But there is a binding available as a jar file for openHAB 2. Or it's also available on the marketplace for openHAB 2. And for openHAB 3, there is a pull request open to get it into the stable distribution, hopefully soon. And yeah, it's a very easy device, battery operated, and yeah, you can just here switch the light on and off. You can also have double click detection and whatever you need. Yeah, very simple device. It's quite nice. It works very reliable, especially the second generation. So yeah, I think it has even Bluetooth 5 and works on quite long ranges. So I like it very much, and I use it for some applications in my smart home. Yeah. Let's come to the next one, which is something very interesting from my point of view. That is Noki, which is this device here. And the Noki device is not something that you directly interact with. It's something that you put anywhere on some surface, like a wall or a cupboard, or yeah, I usually put it under the desk so you can't see it. And basically it listens on vibrations and sound of the surface, and can detect if you knock on the surface. So when I do here like some knock, it will detect it and trigger some actions related to that, gestures that you have configured in your Noki, trigger some actions on your smartphone, smart home, or anywhere. So you see the light were going out quite, let's say, delayed. Yeah, this is very bad thing about it currently. So they promised to bring out an SDK, which did not come yet. So it needs like IFTTT integration to work currently, and that's why you have this very long delay. And so currently, I think it's a very interesting device, but currently I would not, let's say, recommend it for usual smart home use in an openHAB, maybe for some special applications, but not for turning the light on, at least not yet. So I hope the SDK is coming soon so that we can integrate it into, or that I can integrate it into openHAB. Would be very happy to create a binding for that. Now we come to the, let's say, when I ask my guests the most appreciated device in my smart home, and yeah, it's a very expensive device, but I like it very much as it provides many options. It's a Nuimo control. So that's really something special. It's a device that has a wheel on its side, and a touch panel on its front with a LED matrix, and also a haptic button which is under the touch panel. And what you can do here is basically you can have use it as a fully fledged UI for your openHAB. Of course, what it can show, it is of course a little bit limited about the LED matrix. And I was thinking about it, about the question, how do you integrate such a device with all its possibilities into openHAB? And here we have some. And here I have chosen a quite different approach. So I didn't do a binding, as I didn't really know how to, let's say, have the flexibility and the, let's say, easiness I need for the configuration put into a binding. Yeah, I would need like a bunch of rules, and then I would have issues. Yeah, how to show icons on the screen. So basically, what I did is I wrote a separate integration which is parsing the sitemap, and basically you have a limited sitemap syntax that you can use to configure this device. And maybe we can have a short look on it, how it's working. So when I go to the device now, then I can here sliding through the menu, I have configured now on the top level menu, I have configured, let's say, two devices, one or two items, let's say, one item related to the music and one item related to the light. Let's start with the light now. And for example, I can here do a button click and the light goes off and on again. I can do, I can, for example, use a wheel, which is not a touch wheel, but an actual wheel that is really a haptical wheel. Yeah, and then I can here, for example, the same light, I can dim it, for example, and put it up again. The numbers are showing the percentage of dimming the light. And yeah, when I go to the music, you can, I have even, let's say, more sophisticated setup. So on this top level menu, I am, let's say, mounted all my my complete multi-room system. So when I put the button here, okay, that's a little bit loud. The music will start and stop in my complete home. But I can also go into a sub menu and now switch a little bit around between my separate rooms. Where I have my multi-room audio system. I have configured 3 rooms with some letters related to these rooms. And for example, I can here just stay at the room that I'm currently in. And now only my current room is played. And of course, I can adjust the volume with the wheel very smoothly, very nicely. So basically, it's my favorite device for controlling the music. Yeah, let's look into a little bit how the configuration approach works. So what the integration basically does, it's parsing this sitemaps that we see here on the screen, and you just put yeah, let's say some wrapper for each menu and put at least one slider, or not at least one slider. You can also leave out the slider, but then the wheel won't work. You will put you will put an item where you have the control, which usually will be a player or a switch or something. And you will put a slider for reading out the wheel. And you can even, as I just showed, you can even do sub-menus with sub rooms, and where you have exactly the same structure, always the switch or the player, and the slider for having the wheel. And you have an icon library in the background that offers you the possibility to yeah, just choose an icon. And of course, you can also add an icon on your own. Yeah, unfortunately, the Noemo control is not sold anymore on the online shop of the manufacturer, because the manufacturer decided to not support the software side anymore of the Noemo control. But yeah, as I'm in Berlin and they are also in Berlin, I'm in good contact with them, and it is a situation that they have like 100 devices left. I don't want to sell you something, but if you are interested, if you want some, if you'd like to have this device, then it's possible by just writing a mail to them, and then they can give it to you to a reduced price. It's still an expensive device, as it was designed for a little bit more, let's say, sophisticated applications. Originally it was designed, I think, for graphic designers for extremely fine-grained control, for example, choosing colors or having very fine-grained wheel for professional applications. So the wheel accuracy is way more than needed for smart home application. Yeah, so we have 100 steps in openHAB, and I think they have like 5,000 steps or something. So it's a little bit over-engineered for the smart home use case, but I'd really like to use it for this use case. And why I also wanted to show it is basically because of the interesting configuration approach for the sitemap. So that is maybe also some idea for the futures for similar devices that may come up in the future. An interesting option how to configure like user interface devices which are not, which are basically not have a classical web UI or something. Yeah, so I think that was my presentation about input devices, and if there are some questions, I'm happy to answer them.
Fantastic. Thank you so much. And by the way, I still have a bunch of Gen 1 flick buttons, which I've taken apart and put the battery back into it, and we use those for my son to play around with to turn lights on and off. So the last device, it's a shame that's not sold anymore. What's the battery life like on that?
The remote control?
Yes.
I think it's not so good. Yeah. So for usual switches, as I would say, for example, for the second generation of the Flick, it's like 1 year or so, and for the remote control, it's not so good. Yeah, you can put it off, then it will take longer, and I think it really depends how you use this device. So you have an I can maybe if you can put the device screen back on the back side. Don't know if you see that here. On and off button. The device will also go into sleep mode after some minutes. Yeah, and the wake up is basically done semi-automatically. Yeah, so when you use the wheel a little bit, it will not wake up directly, but maybe after 1 second or something. And you can also, to wake up, you can just put your finger on. And so not pressing the button, but put the finger on, then it also wakes up. And of course, if you push the button, then it directly wakes up and sends the command. So it depends how you use it. If you turn it off when you are not using it at all, but I would say it's like 1 or 2 weeks or something. Yeah, so you really have to charge it quite often if you use it on a daily basis or multiple times a week.
Gotcha. Okay. Well, great. Well, I think that's all the questions. So I'm going to go ahead and add our presenters back in here so you can see all of us, so we can say thank you very much. And I appreciate everybody joining us. We are about right at the 2-hour mark, which is fantastic. And as always, you can find us at openhab.org, our community website, or on our GitHub page. And with that, I'll leave it. Any other comments from the presenters you want to make?
Just a last comment. Thank you very much, Dan, for organizing all of that. And I think it was a fantastic meetup. We should do that definitely more often. So expect to have that job in future as well.
I second that.
Yeah.
All right. All right, everybody. Well, thank you very much. And have a good rest of your Saturday.
Thank you. Bye-bye.